Assalamualaikum warahmatullahi wabarakatuh and good afternoon to everyone. Today I would like to share how to perform the circuit analysis for clamper diode applications. Alright, okay, we move to the first question. Okay, figure Q2B1 display the input waveform. Vi for the clamper circuit depicted in the figure Q2B2. Analyze the output voltage Vout with the aid of equivalent circuit and the waveform. So as we know that the function of the clamper is to clamp or shift a signal to a different DC level, right? So if let's say the waveform, the input waveform like this, alright, so at the output side the waveform will be shifted, either up or down, depending on the type of clamper that you use, either negative clamper or positive clamper. Kalau if let's say you use a negative clamper, then your waveform should be below 10, right? Move the clamper, the signal will be moved to downward, right? And if let's say you use a positive clamper, then your waveform, your signal will be shift up. Alright, okay, so now we share with you how to do the circuit analysis for this clamper circuit. Right, okay, first thing first, okay, we need to consider okay, my pen is not working. Okay, alright, okay, first thing first, you guys need to apply during negative half cycle. Okay, during negative half cycle, okay, so basically here, right, the half cycle for the input waveform, right? So your input will be like this, okay, during negative half cycle. Okay, here is your input is negative 20 volt. Here is the input voltage and T. Alright, okay, after that you need to draw the circuit, right? So okay, for the circuit, okay, you need to check, okay, identify whether your diode is a forward bias or reverse bias. So forward bias is a on condition and reverse bias is a off condition. So okay, we try to identify it, okay, during negative half cycles. Okay, we draw the circuit first. Okay, this one for the negative half cycle, so the polarity at the top must be negative, okay, then bottom must be positive, right? The current flow from positive to negative, right? So from this circuit, if let's say during the negative half cycle, your polarity, okay, positive terminal at the bottom and the negative terminal at the top, right? So current will flow from positive to negative. So current will flow like this, alright, then going through to the 5 volt DC, followed by silicon diode and the capacitor. So as you can see, during negative half cycle, your diode, silicon diode, will be forward bias, which is on state. Right, so you can draw like this, okay, negative and positive, right? Followed by the DC voltage here. Okay, then you need to indicate the polarity of your voltage for both DC and diode voltage. Okay, for the diode voltage, this one is plus, this one is minus VD. Right, for the DC voltage, plus and minus. This one is a 5 volt. Right, and you can draw the resistor here. Okay, then here is your output voltage, Vout. Alright, okay, so next, okay, you must follow for the during negative half cycle. There are 3 steps that you need to follow. Okay, step number 1. Okay, this step you can refer to your lecture notes. Okay, the step number 1, you need to find the polarity of VC. Right, VC is a capacitor voltage lah. Right. Okay, so your polarity for the capacitor, okay, must be follow the direction of the current, okay, from positive, from the high potential positive to low potential. So your capacitor polarity must be from positive to negative, from high potential to low potential. So here must be positive and here must be negative, right? Okay, after that, step number 2, okay, you need to determine Vout using Kirchhoff voltage law at output side. Right, so at the output side, this side. Alright, so you must determine Vout using KVL at the output side. So you need to draw the loop here. Right, for example, I draw a loop like this. Okay, then you are able to analyze your circuit using the KVL. So in this case, we're starting from the Vout, okay, negative Vout, followed by, okay, dia akan jumpa, okay, dia akan jumpa the VD lah. Okay, this one is the diode voltage, okay, minus VD SI, right, and then followed by the next component is the DC voltage plus 5 VDC, alright, equal to 0 volt. Right, so you must remember that KVL mentioned that the voltage in the loop is the total voltage in the loop is equal to 0 volt. Right, so this one in the loop, okay, in this loop, at the output loop, you have Vout, and then you have a diode voltage, and you have a DC voltage 5 volt. Alright, okay, so now you can solve this equation. So Vout equal to, okay, negative VDSI plus VDC, right? So negative VDSI is a 0.7 volt. Okay, negative 0.7 volt. Okay, plus VDC. VDC is given in the question is 5 volt. So here you will get 5 minus 0.7 is 4.3 volt. Alright. Okay. Now we move to the next step. The final step for negative half cycle. Step number 3. Okay, you need to determine, okay, the value of VC. Okay, using, again, you need to use a KVL at the input side. Okay, so input this side, right? So okay, you can make a loop here, at the input side. So for example, I just draw a loop for the input side as a counterclockwise. Right, so we're starting from, this one is a V in. We're starting from V in, negative V in, then dia akan jumpa VDC minus VDC, right, followed by positive VDSI, and then plus, here is a VC, plus VC equal to 0, right? Okay, now we need to find the value for VC. So VC is equal to VI plus VDC minus VDSI plus VC. Okay, that's it. VC equal to VI plus VDC minus VDSI. Okay, so as we notice that VDSI minus VC is a V out. This one. V naught equal to VDC minus VDSI. Alright, so VI minus V out. So VI in this case is 20 volt. Alright, 20 minus V out, just now you will get 4.3, right? So we see the answer is 20 minus 4.3, so you will get sorry, this one. Okay, so I made mistake on this. Okay, VI in the question is given 20. VDC is a 5 volt. Plus 5 minus 0.7. Alright, so 20 plus 5, 25 minus 0.7. So you get here 24.3 volt. Right? Okay, so this one during negative half cycle. So now we consider on the during positive half cycle. Right, during positive half cycle, so we consider at the positive side. So this side lah. So VI, your input voltage is 10 volt. VI T. Okay, so the next step is you need to draw the circuit. Alright, just now for the negative half cycle, as I mentioned, you need to put the negative first, followed by positive at the bottom, right? But for the during positive half cycle, you must put positive at the top and negative at the bottom. Alright, then the current flow from the high potential to low potential. So the current flow like this, and this one, when the current flow at the diode, as you can see, the diode will be turned off because diode is in reverse bias condition, right? So you can represent this diode as an open circuit, right? Okay, you can redraw the circuit like this. Okay, the diode will be open because okay, the diode is in reverse bias conditions. Right, here is power positive, negative 5 volt. Positive, negative. Right, so the polarity of the capacitor you must follow during negative half cycle. So during negative half cycle, the diode polarity, okay, at the right is positive, the left is negative. So this one is a VC. Alright. Okay, the last one here, plus minus output voltage. Okay. Okay, so during positive half cycle, so we need to find the V out, right? The output voltage. Okay, how do we find the V out? We need to apply the KVL. So you need to apply KVL, okay, at the input side for you to find output voltage, right? Okay, so here you need to make a loop. Okay, for example, saya buat loop like this. Okay, the counter clockwise. Okay, so this circuit, alright, the diode circuit, as I mentioned to you before, is a reverse bias condition, right? This one, your diode will be turned off. So kat sini, this circuit will be no longer working, right? So this one already disconnect, right? So okay, the current, okay, will flow from here, okay, to here, okay, from positive, then pass through the resistor, and lastly end at the negative terminal, right? Okay, so okay, here you can find the V out using the KVL. So I starting from here. Okay, here is VI. Okay, positive VI. Okay, then you akan jumpa V out minus V out. Then okay, next, okay, you will meet up the capacitor voltage. So plus VC is equal to 0 volt. Okay, then your V out is equal to VI plus VC. Okay, so your input voltage is a 10 volt, okay, from the waveform, okay, input waveform, plus VC, okay, during negative half cycle, okay, we already find the value for the VC, which is 24.3 volt. Then okay, you total between 10 and 24.3, and you will get 34.3 volt, right? Okay, so lastly, okay, you need to draw the final waveform, right? Okay, you can draw the final waveform. Okay, so normally what we did is, okay, firstly you need to draw the input waveform first, right? So this one is the VI, and here is the time, right? So here, at the positive half cycle, okay, your input voltage is 10. Then at the negative half cycle, your input is negative 20. Right, okay, like this one is for your input waveform. So now we can draw the output waveform. Okay, so at the positive half cycle, right? So as you can see in our solution before, so at the negative positive half cycle, okay, your V out will be, okay, you get the value for V out is equal to 34.3. So here your V out is 34.3 volt, and then during negative half cycle, your output voltage is 4.3, right? 4.3 volt. This one is your x-axis T. Alright. So how to draw it? So firstly, okay, you can tarik, you can make a dash line ataupun break line, broken line. Alright. Okay, saya tak ada pembaris, very hard to use pembaris here. Okay, you can, okay, in your paper you can use a ruler, okay, to make it straight. Right, then after that you can draw your waveform, right, like this. Okay, so the pattern of the waveform should be same as what you see at the input. Okay, basically they are sama, they are sama. The waveform pattern is same, but the different is a position, right? Either up, upward, or downward. So in this case, for the positive clamper, okay, this one is a positive clamper. So positive clamper, the output must be go to upward, move to upward. Alright, so okay, for as you can see, the input 10 volt, then the output they increase, they move. Okay, they move to 34.3 volt. Then for the negative half cycle, okay, the waveform move to 4.3 volt. Right, dia berganjak ataupun dia shift. Okay, but dia punya peak to peak voltage, okay, for the waveform is supposed to be same, right? If they say here 10 plus 20, so you will get 30 volt peak to peak. Alright, from this peak to this peak must be 30 volt. Okay, you just tambah aja. Okay, you dapat 30 volt peak to peak. Alright, so for the output you must get the same value. Okay, 34.3 minus 4.3, so you will get here also 30 volt peak to peak. Right, okay, that's it for the solution ataupun method on how to solve the positive clamper circuit. Right, okay, I hope you guys understand for this tutorial. Okay, let's move to the next question for the negative clamper. Okay, figure Q2C show a clamper circuit and the input signal V in. Identify the type of clamper. Compute and sketch the output voltage V out. Assume that Vt for germanium is 0.3 volt. Okay, as you can see, as as we go through before this, right? Okay, you can see that the previous exercise ataupun tutorial, right? The diode facing up, right? The arrow of the diode is facing up. So that one, the type of clamper is positive clamper. And I already show you that there's the waveform. Okay, for the positive clamper is shift upward. Okay, dia berganjak ke atas. Alright. Okay, different for the negative clamper, the waveform will be shifted to downward. Okay, dia berganjak ke bawah. Alright, so positive clamper, the signal ataupun waveform dia akan berganjak ke atas, shift to upward. Alright, and then for the negative clamper, your waveform or signal will be shift to downward. Okay, ke arah ke bawah lah. Okay, so the first question, identify the type of clamper. So the type of clamper is a negative clamper. Right, this one is a negative clamper. Okay, the first tutorial is a positive clamper. Right, so you boleh tengok the direction of the diode. Okay, kalau yang first tadi, diode is facing up. Alright, now for the negative clamper, the diode is facing down. Okay, the second question, compute and sketch the output voltage Vout. Assume that Vt for germanium is equal to 0.3 volt. Okay, so we follow the step by step as what we have did in the first tutorial, right? Okay, for the positive half cycle, okay, so this one we consider. For the negative clamper, we need to consider positive half cycle first, alright, followed by negative half cycle. Kalau untuk yang positive clamper tadi, we consider the negative half cycle first, followed by positive half cycle. Right, so here the input voltage is 10 volt. Right, this one is Vi, this one is T. Right, so we consider at the positive half cycle only. Right, so at the positive half cycle, the polarity for your input voltage must be start with the positive. Okay, positive followed by positive at the top and negative at the bottom. Alright, so the current will flow from high potential positive to low potential negative. Right, so as you can see, when the current is flow, right, it pass through the germanium diode. Okay, what happened to germanium diode? So as you can see, the arrow for the germanium diode is facing down. So that is indicate that your germanium diode is in forward bias condition, right? Right. So forward bias condition means that your diode is turned on condition, right? Okay, so you can represent this the diode symbol. You can represent with the power supply symbol, as the germanium has a voltage 0.3 volt, right? So you can redraw the circuit like this. Minus Vout. Okay, this one is germanium, plus minus VDGE, right? This one plus minus 5 volt. Okay, then here for the positive half cycle, the top terminal must be positive, bottom terminal must be negative. So here is a V in. Right, so sekarang kita nak cari the polarity ya. We need to identify the polarity of the capacitor, right? So the step number 1, Okay, identify polarity of VC. Alright, okay, capacitor voltage. So basically for the negative clamper circuit, alright, so the VC polarity, okay, you must put the polarity, positive polarity, okay, at the left side, and negative polarity at the right side. Alright, so because okay, the current will flow from high potential to low potential, so your polarity, okay, your polarity for the capacitor must be start with the positive followed by negative, bukan daripada negative to positive. Right, so dia mesti follow the right polarity lah, okay, from high potential, low potential, high potential, low potential. Right, so this one is a VC. Okay, the next step is step number 2. Okay, you need to find output voltage using Kirchhoff voltage law at output side. Alright, output side kat mana? So output side, okay, dekat sini lah, okay, area V out ni. Alright, so you can draw the loop here. Right here, I make a counterclockwise loop. Alright, to analyze the output voltage. Alright, so I starting from the V out. So kat sini you can jumpa negative polarity first, followed by positive, right? So you can write negative V out, then you can jumpa dengan diode voltage, which is first this loop meet the positive polarity. So you can write as a positive VDGE. Alright, next dia akan jumpa dengan VDC. Right, the first polarity is positive lah, right, plus VDC equal to 0. Right, so this one is a KVL at the output side. So dia akan jumpa negative V out, then dia akan jumpa positive VD, then dia akan jumpa positive VDC. Right, okay, so you just solve this equation. So V out equal to VDGE plus VDC. Okay, VDGE is a 0.3 volt plus VDC is 5 volt. Then here you will get 5.3 volt. Okay, now we move to the step number 3. Okay, you need to find VC. Okay, you need to find the capacitor voltage. Okay, so here again you need to apply the KVL. Kat sini you akan jumpa kena selalu buat untuk circuit, to perform the circuit analysis you must use the KVL. Right, so you apply KVL at the input side. Okay, macam mana kita nak cari? So you first kali you need to draw the loop. Okay, for example, saya buat clockwise loop at the input. Okay, sini belah sini adalah output. Okay, kat sini adalah input. Alright, so okay, starting from the VI, so first thing you akan jumpa negative VI, then followed by positive, okay, plus VC, then you akan jumpa lagi, okay, kat sini adalah V out lah, okay, lastly you akan jumpa plus V out equal to 0. Okay, kat sini sebenarnya this one is a V out, right? Okay, so V out we already know the value for V out is 5.3 volt. Okay, since this one and this branch, right, and this branch is a parallel. Okay, since those branch are parallel, so the value for the voltage is the same, right? So kat sini semua sama, 5.3, here also 5.3, right? So next, okay, you need to find the VC. Okay, VC equal to VI minus Vout. Okay, VI minus Vout. So in this case, your VI is a 10 volt, right? For the positive half cycle, 10 volt. Okay, minus Vout. Okay, just now you get 5.3 volt, right? So 10 minus 5.3, you will get here 4.7 volt, right? Okay. Okay, we're done for the positive half cycle. Now we need to consider on the negative half cycle. So during negative half cycle, okay, untuk analisis the clamper or clipper, you need to analyze both positive and negative cycle of the waveform. Okay, input waveform. Okay, for the negative half cycle, so you at your circuit here, okay, you can put, okay, for the negative half cycle, the top polarity must be negative, okay, then the bottom polarity must be positive. Alright, okay, so okay, when the current flow from high potential to low potential, from positive to negative, right, the current flow like this, and when this current pass through the diode will be reverse bias. So means that your diode will be turned off, right, because reverse bias. Okay, dia berlawanan polarity lah. So dia akan berlakunya reverse bias kat sini. So your diode will not be functional. Alright. So next, you need to draw the circuit. Okay, this one, as mentioned before, your diode is in off state, so your diode will be open circuit. So this branch will no longer functional. Okay, kat sini dah tak function lagi. Right, so okay, your circuit will be like this. Okay, plus minus V out. So it's a R. Plus minus 5 volt. Okay, polarity for the negative half cycle. So the top polarity must be negative, bottom polarity must be positive. This one is a V in. Right, so the polarity of the capacitor voltage you can follow on the positive half cycle polarity. So which is you must remain the same lah, the polarity as you use in the positive half cycle. So positive, negative. This one is a VC. Alright. Okay. So for negative half cycle, okay, we need to find the value for the output voltage. So this how do you find the output voltage? Using this circuit, right? So if let's say we want to find the output voltage here, you must apply the KVL. Okay, you must apply the KVL. Okay, you perform the KVL. Okay, at the input. So for example, okay, I make a loop first, right? So Okay, you can jumpa the first starting from the input voltage. Okay, negative Vi. Okay, then they can go through on the V out. Okay, negative V out. Okay, lastly is a capacitor voltage, negative Vc equal to 0. Right, so V out, your V out should be equal to negative Vi minus Vc. Right, so Vi in the question is 25. Okay, negative 25 minus Vc is 4.7 volt. Then you will get here negative 29.7 volt. Right. Okay, so lastly you need to draw the final waveform, final output waveform. So you boleh draw, okay, the input and the output waveform, so you can compare it. So we in here is a T. Okay. 10 volt. Here is negative 25. Okay, so it's a input waveform, and then you can draw the output waveform. So output waveform at the positive half cycle. So your output waveform is 5.3. So this, okay, input 10, but the output is 5.3. So for example here I put 5.3. Okay. Okay, then at the during negative half cycle, right, your output should be negative 29.7 volt. Right, so yang ni mesti sama lah. Okay, so yang ni mesti the shape as I mentioned to you before, the shape is not change. Okay, yang berubah cuma dia punya position. Alright. So like this. Alright. So kalau you kira balik the peak to peak voltage from this peak to this peak, here is about 35 volt peak to peak. Alright. Kat sini pun sama lah. It's around 35. Okay, so we get the same peak to peak value. Right, so dia punya shape dia tak berubah, yang berubah dia punya position. Right, so for the negative clamper, the waveform they shift down. Right, for the positive clamper, waveform dia akan ke atas lah, shift up. Alright, okay, that's it for the tutorial for the negative clamper. Right. Okay, so we move to the last question. Right. Question number 3. Okay, construct a clamper circuit to perform the function as shown in figure Q2D. Use germanium diode in your design. Assume that Vt for germanium is 0.3 volt. State any assumption made. Alright, so yang ni dibagi okay, dalam bentuk waveform. Right, so waveform, input waveform, and the output waveform. Then you need to design what kind of the clamper that you need to use. Right, so by analyzing between the output waveform and input waveform, you can determine either this circuit is a negative clamper or positive clamper, right? So kita tengok you can look at the input, right? Input 12 volt for the positive half cycle 12 volt, and then negative half cycle is negative 12 volt, right? For the output, the peak during the positive half cycle, the peak of the waveform, which is a triangular waveform, right, they move downward, from 12 volt move to 5.3 volt, right? Same goes to the during negative half cycle, from negative 12 volt, they move downward to negative 18.7 volt. So means that here we can determine which type of clamper that you use. Kalau tengok kat situ, your clamper, the output waveform is slightly move to downward. Alright, so yang ni you kena gunakan negative clamper circuit. Right, so you should use negative clamper circuit. Sebab apa? Your waveform shift downward, right? Kalau your waveform shift upward, so you need to use positive clamper circuit. Alright, so for the negative clamper circuit, right, you need to design. You need to design the negative clamper circuit. So for the negative clamper circuit, the circuit should be like this. This one you must remember lah, between positive and negative clamper, right? The difference basically is direction of the diode. Yang lain semuanya sama. For the negative clamper, basically the diode facing, the arrow of diode facing downward. Dia menghala ke bawah, right? Dan kalau positive clamper, dia menghala ke atas. This one is your input voltage, and this one is your output voltage. Here is your R, C. This one is a VD. So your VD is, you use a germanium diode. VD GE. Here is a positive, negative VDC. Right, this is your circuit, negative clamper circuit. Alright, so for the negative clamper circuit, to analyze it, first thing first, you need to apply the during positive half cycle and during negative half cycle. Right, for positive half cycle, the polarity, during the positive half cycle, the top polarity must be positive, bottom polarity must be negative, right? The current will flow from high potential positive to low potential. So high potential kat sini must be positive, then your diode, your capacitor polarity also must start with a positive, high potential to low potential. Positive then negative. So this one is your capacitor voltage, right? And then followed by the pass through the diode, which is forward bias, right? Forward bias, and then seterusnya dia akan pergi. Next is VDC lah, right? So this one you can redraw the circuit, to make your analysis much more easier lah, right? So I draw the circuit first. So and you represent this one, this diode, as a power supply symbol. Okay, so plus minus V out. Here is your VC. Here is our plus minus input voltage. Here is plus minus VDGE, and here plus minus VDC. Alright. Okay. Kat sini, okay, during positive half cycle, the value of VI kita boleh dapat daripada input voltage, which is, okay, from the waveform, input waveform, you can get the value for VI is equal to 12 volt. Alright, same goes to the V out. Okay, V out, okay, for the positive half cycle, you will get V out equal to 5.3 volt. Right, semua value ni kita dapat kita boleh dapat daripada waveform, except for the VC and VDC. Alright. Okay, so to find the value for the VDC, okay, we need to apply the KVL. Okay, apply the KVL at the output side. So I make a loop. Okay, here counterclockwise. Right, so starting from V out, okay, you akan jumpa dengan negative V out first, negative V out, and then dia akan jumpa VD, okay, plus. The polarity is very important, so make sure you put the correct polarity to your circuit. Right, so plus VDGE plus VDC equal to 0. Right, so you perform the KVL at output side. Okay, so sekarang kita boleh cari, we can get the value for the VDC, which is VDC equal to, okay, V out minus VDGE. Okay, V out, okay, from the waveform, so 5.3 volt minus 0.3. Right, so you will get VDC is equal to 5 volt. Okay, so next step, okay, you need to find the value for the VC. Right, so VC you need to apply to find VC. Okay, you need to apply the KVL at input side. Okay, input side kat mana? Kat sinilah. Okay, you can make a loop as a counterclockwise or clockwise. Okay, tak kisah, mana-mana pun boleh. Right, for example here I buat, okay, this one saya buat counterclockwise, this one saya buat clockwise, ikut rajam. Alright, so starting from the V in, okay, negative V in followed by VC plus VC, then lastly dia akan jumpa V out plus V out is equal to 0. Alright, so VC equal to V in minus V out. Okay, V in for the positive half cycle is 12 volt minus V out is 5.3 volt. So here you get 6.7 volt. Right, so we get the VC is equal to 6.7 volt. Right, okay, so next we need to apply during negative half cycle. Okay, so during negative half cycle, Okay, this waveform, okay, 12 volt. Right, during negative half cycle, so your circuit, okay, you need to analyze it using the new polarity, right? So okay, for the negative half cycle, the top polarity must be negative, bottom polarity must be positive. Right, so the current will flow from positive to negative. Dia akan flow dari bawah ni ke atas. Right, so what happened to the diode? So diode will be turned off because because it in the reverse bias condition. Right, so when the diode working in reverse bias condition, your diode will be off. Okay, because there is no current flow. Right. So you can redraw the circuit to be like this. So since your diode is off, you can put it as an open circuit. Plus minus V out. Here the polarity remain the same, okay, as in the positive half cycle. So here is negative, positive, V in. Right here, positive, negative, VDC. Alright, this is your circuit for during negative half cycle. So your diode will be turned off. Okay, so during negative half cycle, we need to find the value for the output voltage. Okay, to validate the output voltage at the waveform. So you can tengok dekat waveform ni, the output voltage is 18.7 volt. So you need to validate it, either this output voltage is correct or not, right? So to find the output voltage, you must apply the KVL at the input side. Right, so I make a loop here clockwise. Right, starting from input voltage plus VI followed by VC, okay, followed by Vout. Okay, VI plus VC plus Vout equal to 0. Right, so since we are now I want to find the value for Vout. So Vout is equal to negative VI minus VC. Right, so VI is 12 volt minus VC is 6.7 volt. So here you will get negative 18.7 volt. Okay, which is this value prove that the output value for this waveform is correct. Alright, so you will get through the calculation, okay, you get Vout equal to 18.7, which is similar value with the question, right? Okay, so lastly, okay, if let's say the question you need to construct, so you means that you need to construct the circuit, right, the clamper circuit. So finally you can draw the final proposed circuit, right? So to be like this. Out, V in. This is germanium diode. This is plus minus VDC, which is 5 volt lah. Okay, so plus minus VC. Okay, this one is your your final circuit. Alright, so make sure you draw the final circuit. Alright, if let's say you don't want to lose the mark. Alright, I think that's it for the design question. Alright, I hope you understand. Okay, as usual, I provide you some exercise to test your understanding for the clamper circuit. Alright, so okay, I provide you two questions. Okay, question 1. Figure Q2B show a clamper circuit. Analyze and sketch the output waveform voltage Vout. Assume that VGE equal to 0.3 volt. Alright, so please do it by yourself. Alright, so I already provide you with the final answer. Alright, similar goes to the question number 2. Right, so design a clamper using ideal diode to perform the given input and output in figure Q2C. Right, so design a clamper, so you must provide with the final proposal for your clamper circuit. Alright, so here your final answer. Alright, I think that's it for today's video. Okay, see you on the next video. Okay, thanks for watching.